evening tonight we'll be doing graphing and labeling points. They will be in the form of x comma y. X's mean you're going to be going left or right. Negatives will be left and positives will be right. And so in the next form, in your y, you will have up and down. Up will be positive and down will be negative. In the quadrant below, we'll be graphing the following points. We'll do -3, 5, 4, 3, 3, 4, all right, so here's these points. We're also going to label those points. So -3, 5, first of all. -3 means we're going to go left 3, up 5, because 5 is positive. Then beside that, we're going to write -3, 5. Hopefully you can do that a little bit smaller on your papers. 4, 3 means we're going to go right 4, since right's positive. 3 is also positive, so we're going to go up 3. And that point would be 4, 3. 3, 4 will be pretty close to there. We're going to go right 3 and then up 4. Next, we're going to label some points that have already been given on the graph. So let's draw one in there, and there, and let's go right here. So this first one that I did, we'll call this A. A is left 6 and down 4. So we're going to write -6, -4. So negative sign didn't show up there. Let's call this one B. And the next one C. B, how far did I go left? This is something that gets really weird, is that since I've gone left and right 0, my first number is 0. Then I've gone down 4. A lot of people confuse this and they just write -4, or hopefully you guys aren't having problems with that. C, I've gone right 5, so and since it's positive, it's a positive number, and I have gone down 6. Down 6. Let's add in another point. Let's label a D up here in the corner. D. I've gone left 7. Left is negative. Up is positive. So up, I've gone up 8. So -7, 8. The next thing we'll be doing in section 1.1 is determining whether each ordered pair is a solution of the given equation. So, for example, sorry about that. For example, number 10 on page 72 has the problem 1/2, 8, -1, 6, and we want to see if that fits in to the equation y equals -4x plus 10. It has absolutely no bearing on the situation how this equation is set up. We're going to plug in the x's in for x's and the y's in for y's. We're going to do one at a time, but right now my thing is frozen. Okay, so we're going to check if 1/2 8 is a solution. Let me get my pen. So since 8 is our y, we'll have 8. We're checking to see if it's equal, so we have a question mark over it. We have -4, 1/2 times 1/2 plus 10. Forgive my handwriting a little bit. So we have 8. Is that equal to -4 times 2 is -2. 1/2 of 4 is 2. So plus 10. Is -2 plus 10 equal to 8? Yes, that's 8. So that works. We're going to write a little check mark, and we're going to write 1/2, 8. Whoops, not an equal sign. Ignore this piece right here. Is a solution. All right, and then we're going to test to see whether or not 1/6 is a solution. Negative 1/6. 6 is your y, so I have 6 equals negative 4 times negative 1 plus 10. So I have 6, is that equal, so question marks again. Is that equal to positive 4, because a negative times a negative is a positive, plus 10. 14 is not equal to 6, so negative 1 comma 6 is not a solution. You were probably pretty familiar with graphing in the form of y equals mx plus b. That's an m. Today what we're going to do is graph things in the form of ax plus by equals c. Probably what you guys have always done in the past is tried to solve for y. That can get really gross and messy, and we don't want to have to deal with all that stuff. So what we're going to do is find where the actual x and y intercepts are. The x-intercepts happen at, we're going to call it a comma 0. To find that, we let y equals 0, and then we're going to solve for x. To find the y-intercepts, I'll actually spell out intercepts for you. Y-intercepts happen at just the generic 0 equals b. B is your y-intercept. That's where we call b up here too as well. B is your y-intercept. We're going to let x equal 0. So we have x equals 0, and then we will solve for y. Let's change this into, instead of 4y, how about 4y? An example of doing this will be solving or graphing 2x plus 3y equals 18. So what we're going to do, we're going to solve for the y-intercept first. So solving for the y-intercepts, we plug in a 0 for x. So I'm going to have 2 times 0 plus 3y equals 18. 2 times 0 is 0. 0 plus 3y equals 18. 0 plus 3y, that's just 3y equals 18. Divide by 3, divide by 3. Y equals 6. Then let's go ahead and solve for the x-intercepts in blue. X-intercepts, we set y equal to 0. So we're going to plug in zeros for y's. So I'll have 2x plus 3 times 0 equals 18. 2x plus 0, we're going to skip writing out 0 plus 3y like we did over here. So we'll just have 2x equals 18. We know that this is going to go to 0 there. We're going to divide by 2, both sides, x equals 9. So I just inserted a graph. So now we're going to go ahead and graph that. So in purple, I have y equals 6. So y equals 6 is right there. That's my y-intercept. My x-intercept then, since I did it in blue, I'll do it in blue over here, is 9. And then I'm going to try to connect those lines. So connecting lines is pretty hard for me on this thing, so you get what you get. You guys need to be better than me. You may already know how to graph quadratic functions, and you may just already plug them straight into your calculator. You might already be used to doing that. In this case, we'll have y equals x squared minus 9x minus 12. We will go over calculator kind of stuff later and different ways to actually graph this. Right now, what we're going to do is I generally pick 5 points to plot for quadratic. In this case, I'll just pick some random numbers for you. Let's do -3, -1, 0, 2, 4, and 5. I have no idea why this is so shaky right now. Weird. These are x's that we're going to plug in to every x that we see. So I'll do a couple out with you. So we'll have -3. Make sure you put that in parentheses, especially if you're typing it in that calculator. Minus 9, instead of an x, we're going to write -3. So I about wrote x again, minus 12. When you evaluate that down over off the side, we're going to get 9 plus 27 minus 12, which is equal to 24. So I didn't really finish setting up my little chart here that I usually do. I usually do all my work in that middle, and I do my y at the end, so I'll get 24 over here. Then over here I'll have -1 squared minus 9 times -1 minus 12. When I do that work over here, I'll have 1 plus 9 minus 12, which will get me -2. So I went ahead and I figured out the rest of these, so if you guys want to write that out, it's fine. If not, that's the gist of it. Then what we're going to do is we're going to plot these points. Some of these are obviously not going to fit on our graph over here. I would expect you guys, if you had a question like this, to either make your own graph or rescale a piece of graph paper. In this case, we have -3, 24. It'd be -3 up 24. That's not going to fit on there. -1, -2. So I'm going to go left 1, down 2. So that's that first point that I can plot. That's that guy. Then I have 0, -12. I can pretty well make him fit on that one. -26, that guy's not going to fit. That guy's not going to fit. That guy's not going to fit. Then I have 10. This is a 10. I added that one so that I could get a real flow of the graph here instead of just 2 points. And at 10, we will be back up to -2. And if you guys are familiar with quadratic functions, we make a U shape that is called a parabola. Next, we're going to do the distance formula, which we always just call little d. Okay, in just mathy terms, it's just x2 minus x1 squared plus y squared minus, or y2 minus y1 quantity squared. Now these 2 points would be, or the distance would be between x1, y1, which is just a generic point, and then the distance between x2, comma y2. Okay, so let's put some numbers in there and see what that's actually going to look like. So if I have -2, 2 and 3, -6. Okay, so this would be my x1, y1, x2, y2. So I can plug that in the formula. Okay, think about this as just the difference between my x's. I don't like writing it all out, and that's a pain in the butt to do that much work too. Okay, what is the difference between my x's? -2 to 3. The difference between -2 and 3 is 5. I have 5 squared. The difference then between 2 and -6, the difference between 2 and 6 if I were on a number line is going to be 8. 8 squared. Okay, then I'm going to square those things, and I will have 25. Sorry if you just heard a fart, my baby's eating right now. Plus 64. 25 plus 64 is 89, and I get the square root of 89. Square root of 89 is about 9.4. So the distance between these 2 points is about 9.4. We can only estimate because 89 is not a perfect square root. All right. The other way that I like to think about it, I like to actually plot these points, and maybe you can even just do it in your head. So I'm going to go left 2, up 2, -2, 6, and right 3, down 6. Right 3, down 6. If you are familiar with your Pythagorean theorem, I can make a right triangle out of this. I could also make it on the top here, right here. Okay, what is my distance here? My distance between here and here is 8. the distance between here to here is 5. That's all the distance formula is my Pythagorean theorem. So again, if you remember, this is A, B, and C are my side lengths. Sorry that my tablet's getting a little squiggly. So my Pythagorean theorem is a squared plus b squared equals c squared. And if you don't know this already, then just go ahead and use the distance formula just like we just did. We will get to this Pythagorean theorem eventually and learn it a little more in depth. Okay, a squared is 8 squared plus b is 5, so 5 squared equals c squared. I'm going to add these together, pretty much going to do the same exact things that I just did. I have 64 plus 25 equals c squared. I'm going to add those together to get 89 equals c squared. And to undo a square root, or a square for the c squared, I take the square root. Right here, I get c, I'm writing it in the opposite order, and that's fine, because things on either side of the equal sign are the same thing. The square root of 89, which is about equal to 9.4. That's an easier way for you to remember the distance formula, because this is a kind of gross thing to remember up here at the top. The midpoint formula is the next thing we're going to cover. It generally looks like x1 plus x2 over 2, y1 plus y2 over 2. And that would be to say that your original points are x1, y1, and x2, y2. Okay. I generally think about the midpoint formula as being the average of the two x's and then the average of the two y's. So I add them together, divide by the number of items I have. I have 2 items. So add them together, divide by 2. Some example points are -4, -2, and 2, 5. So I want to find the midpoint of these. So I'm going to average 4 and 2. So I have -4 plus 2 divided by 2. And then I'll do -2 plus 5 divided by 2. So 4 plus 2, -4 plus 2, I'm sorry, is -2 divided by 2, and I should get -1. Then 2 plus 5, -2 plus 5 is 3 over 2. That doesn't simplify down anymore, and we're just going to leave it as 3 halves. I really prefer mixed fractions at this point in your math career, or I prefer improper fractions to mixed fractions. Next thing in this section is doing the equation of a circle. The center there is at HK. Again, that's in the XY format. And the radius that might be given, you might have to find the radius using the distance formula of R. Okay, your generic equation is x minus h squared plus y minus k squared equals r squared. This is also very similar to the distance formula and also your Pythagorean theorem. Kind of notice how this is the difference between 2 points, this is the difference between 2 points. When we're given an HK and a radius, we only plug it in for the h and the k in this equation. The x and the y will stay as an x and a y. So, for example, I may be given that my radius is 5. Radius 5, that's a 5. And my center at 3, -7. Okay, this is really simple to write. My radius 5 will go on this left side. It doesn't really completely matter what side you put things on. X minus h, my h in this case is 3, squared plus y minus 7 will actually be plus 7 squared. My r is 5, so I would have 5 squared, which will really be 25. So what I'm going to actually do is I'm going to erase this and write 25. So hopefully you're taking notes in pencil. The other thing that seems to happen a little bit, it may give you the center and another point of the circle. So what you guys will have to do is you'll have to find this distance. You'll have to use your distance formula to find that distance. The other thing that kind of is a little bit tricky is it'll give you 2 points on the end of a diameter. Remember that a diameter is twice the radius. So what you guys will have to do is find this midpoint, and then you'll also have to figure out what the length of the radius is. All right, good luck. We'll be working on this tomorrow.